Hi there, this is another video from me. It's about these very cheap data modules. You can get them on various online stores, and the complete set including the receiver and the transmitter did cost less than €1. That's incredibly cheap. Anyway, there are two units. This is the transmitter unit. On the other side there are some surface mount components that look like transistors and some capacitors or resistors, I don't know, I haven't had a closer look. Anyway, here is the receiver module, and what these things do is they can broadcast data from the transmitter to the receiver, and I think they can make around 4 kilobit or byte. I'm not sure which one is I'm not into that digital stuff that much. But anyway, you can use them for broadcasting or transmitting data. Often they are used, for example, in a wireless temperature sensor from a wireless thermometer to broadcast the information what the temperature is from the transmitter to the receiver, and it can then be displayed. Of course, you can also make your individual data configuration, but it's microcontroller stuff where I'm currently not really much into. If we have a look at these things, how they work, I had a look, and they are made very obvious. So here we have the transmitter. The data pin goes to this big coil, so you can see it. It goes to this big coil, and that's what makes this thing here a question mark, because this upper device here can be either a transistor or a voltage regulator. I'm not sure what it is. There are some parts that look like resistors, so it's like a voltage divider, and it's some kind of voltage regulator circuit. I'm not sure, but what wonders me then is that the data pin goes directly to plus, because the voltage regulator then would be supposed to be in the minus from the oscillator. But anyway, so I made a question mark. So the device has this round thingy that looks like a small battery, but it isn't. It's like a crystal. But it's not really a crystal. I don't know the name now for these things. I think it's a SAW resonator. This is how they are called. And this is basically a crystal controlled oscillator on usually 433.92 MHz. Let's have a look at the receiver. The receiver uses a signal amplifier on the input. Then it has the actual receiver, which usually is a super regenerative receiver, and that's also the reason why they're using this RF input amplifier. Since super regenerative receivers are also quite sensitive, you actually wouldn't need that amplifier, but since they are producing a lot of RF noise, if you want to call it like that, they are using an amplifier to keep the RF noise away from the antenna. On the output they have a Schmitt trigger circuit made with the integrated circuit that you can see here. This is a LM358, I think it is one. I had a look at it and I think it was a LM358 IC, and it is used to generate a good square wave signal. Because you have digital data, you want to have a good square wave signal. So that's mainly how these simple receivers work and how these simple devices work. Although there is not much on the circuit board, I think the price is really nearly incredible. I mean, less than €1 for both complete units. You can plug them in and they work. That's really a very good price. In the next video we are going to have a closer look at the transmitter unit. Okay, best regards, Stefan. So now I'm going to show you how to transmit with the transmitter module. Here is my receiver, and I've already hooked it up to 5 volts from plus and minus, which is this lead, but there's no signal. But as soon as I bridge the data pin to the plus pin, it's transmitting. So here you can see the bridge. If I pull out the bridge, signal disappears. You wonder how you can broadcast audio with it. Well, you go ahead and add a resistor between plus and data. It's the first thing that you do. So if you have a look at the schematic, you add a resistor between plus and data. It's a 2.2 carrier resistor in my case. And you add a coupling capacitor. This is a 1 microfarad capacitor on the data pin, and you want to have plus on the data pin. Then you reduce the voltage to 3.3 volts, which is also a typical digital voltage, And now you hook up your audio source. Hook up ground to ground and the audio signal to the other side of this capacitor. Just a moment. We'll change that a little bit. So I want it to be on 3 fields, not on 4. Now there we go. So now I hook it up there. And I have to change it to AM, of course.
Testsendung über das selber gebaute Walkie-Talkie mit 4 Transistoren hören. Video zur Beschreibung der Grundfunktionen eines einfachen.
So this is how you can broadcast in AM with one of these modules. Keep in mind that if you are doing it like that, so hook up a 2.2K resistor from here to data and connect the capacitor, 1 microfarad with plus there, and add audio there and there, then it will broadcast audio, but the transmission power is very low. It's like below 1 milliwatt, I'm guessing, so it's just like you can play around with it, because as I said, these modules aren't made for that. There is a way to get out more transmission power out of these modules, and that's very simple, because you can go ahead and bridge the data pin directly, and then you can modulate this complete module with an audio signal. For example, you could bridge the plus to data, and then you can, since plus and data is bridged, you have high power transmission, and then you can use a LM386 or something like that to modulate it. But the modulation quality, I found out, is very good if you power it on low power. Okay, that was about the transmitter module from this 433.92 MHz system. So now I have the receiver set up here, and I'm tapping it off of the data pin. So I have an audio amplifier set on the data pin, and let's have a listen how it sounds. If I get the contact. Well, not really sounding too well. And now I'm going to change the module, which is not too easy with one hand. So this is a modified module, and this modified module is now different, because now I'm tapping off the signal behind the receiver, not behind the Schmitt trigger, where it was before, where this output pin is. I'm tapping it off now behind the receiver, as you can see here. So now let's have a listen and see it works. So this is how you can broadcast audio with one of these RX-TX modules. So this is something about these modules that I noticed when I was working with them, and it's really strange. If you have a look at the transmitter board back, you can see that there is a part not mounted. This is this part. And if you follow the traces, which is of course easier off camera, you will see that's kind of going from the oscillator input to ground. So I think there should be mounted like a 1 nanofarad or so blocking capacitor that shortens out the RF from the oscillator to ground. But hey, the oscillator is working, nothing wrong there. I did make some off-camera tests, and I was able to get it to stop oscillating, or when I was powering it up I had to touch it to start oscillating, but I wasn't using it in its specs. I was broadcasting speed with it for a range test and that's not how it's supposed to be operated. As you could see in the previous part, if you just pulse data pin, it does work fine. The more weird thing is the receiver. I wanted to take the receiver outside with my amplified speaker and make a range test, show you that they can get like a few hundred feet range with the original receiver without putting much effort in it and so far and so on. I went outside, and like 100 feet or so, the signal was very weak, it was inesthetic, it was barely readable, it was very bad. And so I assumed that they have aligned this coil here, but something isn't really aligned too well. And so, as I said, I have two circuit boards. I removed this sticky glue and then I tried to realign it with the screwdriver. And first thing that I noticed is that you can align it very well, so it's very comfortable to align. You can align the frequency very simple, and it also stays on the frequency if you take out the screwdriver, nothing wrong there. Very good. But I'll show you the circuit now in a close view, and eventually you will notice it by yourself, because I noticed it, and it was the reason why there was no range. So try to figure out what's wrong with this board, and also with the other board. So, eventually you've already found it. Here is obviously the transistor for the super-regenerative receiver. Here is the filter coil for the input, it's like a bandpass filter, and here is the antenna connector. So, what's missing? Well, if you look at here, you can see that there are 3 spots that have already been pre-welded, pre-soldered, not welded, pre-soldered. They have been pre-soldered, and there would be enough space, or that's just the space for a transistor, but hey, there is no transistor. So they have mounted the resistors and capacitors and everything for the RF preamp, but they have not mounted the RF preamp transistor. And that makes the actual antenna input quite pointless. Well, it does bring a little bit if you hook up the antenna there, but not much. So I changed it, and I hooked up the antenna directly on the super-regenerative receiver. An effect of that, an effect is that the range really improved. It goes much further now, but still it's not a decent range. So you could say this is very weak. No, because I have made some field strength tests. Yeah, let's say with experience bonus, because I'm very experienced with the stuff, as you know, due to my long electronic learning phase. And I made some field strength tests, and I'm sure I can get with ease 1 mile range out of this module to my communications receiver that you saw previously. I can get easy 1 mile range with this module, and even more if I have physically line of sight from the transmitter module to my receiver. So these are going very far. But just with this receiver I was not getting a good performance, or a filmable performance. I think if I have line of sight this will go like 300 feet, 500 feet or so, but not much further. So I just wanted to show you that because it's really weird. And the other thing that I noticed is if you have a look at this board, it's cut over there, and this board has this additional thing which is very confusing, because first I thought this is the antenna here, so you have to hook up the antenna there on this pin, and I really tried around a while to figure out where the antenna is supposed to be. But yeah, that's pretty much how you want to align them. And for those who have these modules and don't know how to use them on the transmitter, the pin layout, because it's a little bit confusing. So the both middle pins are data output, and the pin on the left side is the voltage input, and the pin on the right side is the ground connector. So for those who are having these modules, this is how you can hook them up, because the transmitter module is has some letters on it and tells you where to connect what. Okay, that's about these wireless 433.92 MHz data communication modules.
Meter, 45 feet, 20 meters.